Hello everyone, this is the last lesson of Chapter 8, Perfect Squares. In this lesson, you will learn how to factor perfect square trinomials as well as solve the equation involving perfect squares. Before we begin, I strongly encourage all of you to watch the previous lessons because this last lesson will be more like a review of what you learned. I'll also upload chapter review video shortly to give you an idea from lesson 1 all the way through lesson 9. From lessons 6 and 7, I believe, when we were learning about the perfect squares are a trinomial of the form a squared plus 2ab plus b squared or a squared minus 2ab plus b squared. Here's an example number 1. Recognize and factor perfect square trinomials. Determine whether 25x squared minus 30x plus 9 is a perfect square trinomial. If so, factor it. What I'm going to do is I'm going to use the method that I shared with you on last lesson. When you have an expression, make sure that you have ax squared plus bx plus c form. And once you do, I'm trying to find what two numbers do you need to multiply to get ax squared. In this case, let's just try with 5x. 5x times 5x will get you 25x squared. And same thing, you will find what two numbers do you need to multiply to get the c value. In this case, if I multiply 3 and 3. Now you're going to cross multiply from your a to c. 5x times 3 is 15x. And since they are identical, 5x times another 3 will be also 15x. What you're going to do is when you add them, I have to get the b value. In this case, you got negative 30x where I have positive 30x. Since my number is very close, I'm going to change my sign simply by putting negatives on the 3's because negative 3 times negative 3 will still be positive 9. So now 5x times negative 3 will be negative 15x. 5x times another negative 3 will be also negative 15x. And when I add them, negative 15x plus negative 15x, they should get negative 30x. So this is how I know this has been checked. When you're writing it, remember that I write across. So we're going to write 5x minus 3 from this side. And the next one goes on the bottom, 5x minus 3. Since here they are identical terms, I can combine them saying 5x minus 3 to the second power. If I'm looking at it, this is a perfect square form where you had a plus b squared or a minus b squared. And that's how I know this has been factored. Part B, determine whether 49y squared plus 42y plus 36 is a perfect square trinomial. If so, factor it. First, checking this is ax squared plus bx plus c, where the x's are replaced with the y. Let's try by writing 7y times 7y. 7y times 7y will be 49y squared. If I have 36, when I have 6 times 6, it will get you 36. When you cross multiply this, 7y times 6 is 42y, and then 7y times 6 is also another 42y. Now, by looking at it, it doesn't look like they're going to add up to 42y. They're obviously over 42y since you're adding the 42 twice. So let's try another one. Before you say it's prime polynomial, you have to try every possible ways. And this method was based on guess and check. So try to do it at least 3 times with another combination until you are for sure that there's nothing else. What if I try 49y with 1y? They will multiply to 49y squared. And in here, I don't really see any numbers because when you cross multiply, it will obviously over 42. So what if, let's say I do 36 and 1 in here, then this 2 becomes 49y, where y times 36 will be 36y, and when I add them, they're still over 42y. It's also not like when I can take out greatest common factor because 49, 42, they have common multiple of 7, but 36, when I'm including all 3 terms, they don't have anything in common. So I believe this is a prime polynomial, which means it cannot be factored anymore. This is the answer of my part B. Again, I said I will do a review for this chapter when I'm including it. I will talk about what method that you can use for certain different cases. Anytime when you have greatest common factor, please try to simplify as much as you can. When you have 2 or 3 terms, you're going to check for a difference of squares or a perfect square trinomials. Difference of squares were a squared minus b squared, where when it was perfect square trinomials, these are like a plus b squared or a minus b squared. When you have 4 terms or more than 4, if you remember, we tried to group them. So for example, like right here, when you had 4 terms, we tried to separate, and from separated groups, what do they have in common, and take that term outside and then try to figure out what do you need to multiply to get the number back. And once you do, you'd realize that they have still the same group. You are going to take out the same groups and just write down what's remaining, because 4y plus 3 times 3y will get you this form back as when you're distributing. Same thing up here. If you had 4y plus 3 times 2, you will get this term back. Example number 2, we're going to factor completely. In here, I'm going to try to see if they have anything common. So in here, when I'm looking at it, the first thing that comes to my mind is when I had a squared minus b squared because of this subtraction right here. Except that 6 nor 96 are not perfect square numbers. If I take 6, let's see what happens. I have x squared on here. 6 times 16 will get you 96. So in here, it looks like now more like x squared is a square of x, where 16 is a square of 4. If I rewrite this just one more time, x squared minus, I'm going to write 4 squared. Do you see how this polynomial matched with a squared minus b squared? A squared minus b squared was when you had a plus b times a minus b. So overall, this becomes 6 times x minus 4 times x plus 4. And this is going to be a factor form of 6x squared minus 96. And as you see, there is nothing else you can do. Part B, when you have 3 terms, we're going to use the method of me writing ax squared plus bx plus c, where what 2 numbers do you need to multiply to get ax squared? In this case, I'm going to have, let's just try with 4y's. 4y times 4y will get you 16y squared. In this one, I need to multiply 2 numbers to get negative 15. Let's just try with negative 5 and 3. If I had 4y times 3, I'll get 12y. When I had 4y times negative 5, I'll get negative 20y. 8y, which is very close because I was supposed to look for positive 8y. Now, what if I change this into positive 5 with negative 3? If I do so, this 2 becomes 4y times negative 3 becomes negative 12y. 4y times 5 is positive 20y. And when I add them, I do get 8y. So that's how I know this works. One more time, just be careful. You're not writing 4y minus 3 as a group. You're writing across. So I'm going to write 4y plus 5 times 4y minus 3. This will be a factor form of part B, and always you can double check by distributing. We've been constantly looking at the zero product property to solve a equation involving perfect squares. In this case, let me just show you one more concept. You may also use square root property below to solve certain equations. The square root property means when you have x squared is equal to n, in order to solve what is x equal to, you need to find the inverse operation of square. When I was asking this question to my students, most of them say the opposite of square would be cube, which is not correct. The inverse operation of square would be square root. So for example, if you had x squared is equal to 9, in order to get rid of the square, I'm trying to think what 2 numbers do you need to multiply to get 9, which is the same concept of when you have x is equal to square root 9. Here's the problem though. When you are thinking about 2 numbers, if I had 3 times 3 will get you 9. But there's one more. Do you know what that is? Another number that will square to make 9 is negative 3. Because the concept of double negatives will make positive, when you have negative 3 times negative 3, it will still be 9. That's where this plus or minus sign came from. So when you're writing this, if x squared is equal to n, when you take the square root on both sides, x is equal to plus or minus square root of n. This is something that I really want you to be careful because your answer from now could be 2 different numbers. Here's an example number 3. Solve equations with repeated factors. As you see, the difference between number 3 and number 1 or 2 is that on number 3, you have an equal sign, which means we are going to solve the equation. In order to solve the equation, again, we're going to use a zero product property. The first thing that you have to do is to set this equation equal to 0. In order to do so, I'm going to add 81 on both sides. You'll have 4x squared plus 36x plus 81 is equal to 0. Now repeating the similar step of when you have trinomials. 2x times 2x will get you 4x squared. If I had 9 times 9, it looks like I will get 81. 2x times 9 is 18x. Again, 2x times 9 is another 18x. When you add them, do I get 36x? The answer is yes. So this one works as long as you write in 2x plus 9 times 2x plus 9, which can be written as 2x plus 9 squared. That is equal to 0. Just to give you a side note, in the past, we've been using something like 3x plus 3 and I don't know, 4x plus 4 is equal to 0. And then you were supposed to set this one is equal to 0 or that one is equal to 0. On this case, you have the square. So before you do this, you have to get rid of the square by taking square root on both sides. If I take the square root on both sides, square root with square will be canceling each other because they're inverse operation. You will have just 2x plus 9 is equal to square root of 0 is, well, 0, and they don't have plus or minus sign. And when you solve this by subtracting 9, 2x is equal to negative 9, x is equal to negative 9 over 2. And this is going to be your answer of part A. To continue, here's another problem. Solve 9x squared minus 30x plus 25 is equal to 0. First, in order to solve this, we are going to factor them. In here, if I factor them, you will have 3x times 3x will get you 9x squared. If I had 5 times 5, you will get 25. When I cross multiply this, 3x times 5 is 15x. 3x times 5 is also 15x. And when I add them, let's check if I get the b value. The answer is no, because I need to have negative 30x, not positive 30x. What if I just change this slightly by putting negative in front of 5's? So if I had negative 5 times negative 5, I still get positive 25. 3x times another negative 5 will be also negative 15x. And when I add them, I do get negative 30x. So that's how I know this can be written as 3x minus 5 times 3x minus 5 is equal to 0. You can solve this by setting this one equal to 0 or that one is equal to 0 where they're identical. So that's up to you. Or I can just do 3x minus 5 squared is equal to 0 by doing one more step. If you do so, again, you're going to want to get rid of this square by taking square root on both sides. And this becomes 3x minus 5 is equal to still 0, and 3x is equal to, if I add 5 on both sides, this will become positive 5. So x is equal to 5 over 3. And this is going to be your answer of this part B. Example number 4, use the square root property. In here, what you will see is they're already in factor form that is equal to not 0. So in this case, we're going to approach this similarly by taking square root on both sides. If I do so, square root and square are inverse operations. They will cancel each other. All I get is b minus 7. Now here's the problem. When you take the square root of 36, you're trying to think what two numbers do you need to multiply to get 36. One of the answer can be 6 as usual. So 6 times 6 will get you 36. However, there's also one more. If you had negative 6 times negative 6 will be still positive 36. So what I'm going to do is I'm going to write plus or minus 6 on the other side. In this case, if you continue to solve, I'm going to add 7, which makes b is equal to plus or minus 6 plus 7. There are going to be two answers. When you have positive 6 plus 7, I will get b is equal to 13. Or if you had negative 6 plus 7, I will get positive 1. So that's how I know this one will be your answer. And let's just double check by plugging in. Begin with 13. If I have 13 minus 7, I will get 6. 6 squared is equal to 36. So that's how I check. If I put 1 in here, 1 minus 7 is negative 6. Negative 6 squared is also 36. So that's how I know this will work. Part B, in order to solve x plus 9 squared is equal to 8. One more time, since this is already factor form that is equal to not 0, only option is take the square root on each side to get rid of the square and solve it from there. If I do so, these two will be gone. All I get is x plus 9 is equal to plus or minus. Now, what two numbers do you need to multiply to get 8? You might have thought about 2 times 4, but keep in mind they have to be identical. There are no integers to make positive 8 when you multiply two identical numbers. So if I use a calculator, if I take square root of 8, x is about to 2.82, and this is irrational number. If I put 2.82 right here, then I'm going to solve this by subtracting 9 on both sides. X is equal to plus or minus 2.82 minus 9. Using calculator, X is equal to, if you had positive 2.82 minus 9 is equal to negative 6.18, or if you had negative 2.82 minus 9, it will become negative 11.82. So this is going to be my solution of part B. And you can double check your answer using graphing calculator. Graph y is equal to x plus 9 squared and y is equal to 8 and see where they're intersecting. On my graph right here, the blue line is your x plus 9 squared, where the red line is representing y is equal to 8. They look like they're intersecting at 2 points. One is right here. This is about negative 6.17, where this point right here, this is about negative 11.82. So that's how I can check that this is going to be still my solution. The last example of this lesson will be real world example. Please pause the video at this point and read the instruction on your own. They're saying this situation can be represented by the equation h is equal to negative 16t squared plus h0, where h is the height in feet of an object dropped from an initial height of h0, and then t is representing time in seconds. Use this model to determine approximately how long it took for the book to reach the ground. If I'm reaching the ground, my height will be 0. If I use this equation, you will have 0 is equal to negative 16t squared plus h0 was given as 5 feet, so plus 5. If you solve this by subtracting 5 on both sides, negative 5 is equal to negative 16t squared. You're looking for the t value. So in order to have t by itself, first get rid of this negative 16 by dividing by negative 16 since they have multiplication. Knowing that this is simplified fraction, in real life, we don't really use time with a fraction, so I'm going to use a decimal. If I use a calculator to divide them, you will get 0.3125. That's equal to t squared. I hope that you're not trying to find what two numbers you need to multiply to get 0.3125 on your own, because it might take time. So to save your time, what if I use a calculator? 0.3125 square root. T is about plus or minus 0.56. Since t is representing the time, we cannot use negative in this situation. Thus, your answer will be just 0.56 seconds, and that is equal to your t, and this is going to be your answer. This is the end of the lesson. Thanks for learning with me. If you have any questions, please leave a comment.